In last session, we seen mixed compression supersonic intake system when we are applying bleeding. So in the last video, whatever we seen, that is called porous bleed, because the hole size is very small. When the hole size is very small, we will be calling as a porous bleed. Now we can increase number of porous, that is holes. Okay, one, two, three, four, five. But if you see the second type, we'll be calling as a uh, slot bleeding. If we see the cross section, here it is rectangle, but it is here the size of the rectangle is very large compared to the porous holes. So if you increase the diameter of the slot, we will be calling as a slot bleeding system. So we will try to see the slot bleeding system today. So this is the another image which shows you slot. You can see this is the slot. It was larger hole was created from through this the air was discharged to the outlet. Okay. So this is we'll be treating as a outlet to in our analysis. So we'll try to do this slot bleeding system simulation today. So we already done geometry preparation in the last videos. I will be opening this geometry once again. So this is the geometry window we designed in the last video. So if you go to sketching, we can see we created a two porous holes. If you zoom, we can see these are the two porous holes. This is one. This is another one. Now what we try to do, we will try to create a large porous. Before that, what I'm trying to do, I will try to trim these porous whatever we created in the last session. So I will be deleting this complete inclined line. I will go to draw. I will be drawing a line from the center point to this end point. Now, similar to last video, now what I'm trying to do, I will try to take a line and I will be drawing a line which is perpendicular to this inclined line. So I will be making this new line perpendicular to this inclined line. I will going to dimension angle. I will select this first in line, second line. So this is my angle A37. A37 is 92, but I need to make it to perpendicular. So A37 is 90. Now after that I will be drawing another line. So this line should be parallel to this previous line. So I drawn a line. I will make it parallel. In constraint, I have a parallel option. I will select first line and I will select second line. Now these two lines are parallel to each other. Now I will try to give dimension between these two lines. I will take length distance. So I will select first line, second line. Now I will be giving distance between these two lines, that is L37. L37 I will be giving as a 20, if you see. So this is my largest slot now. This is my largest slot now. So what I will try to give, I will try to give a length between this center point to this line. So I'll be giving length between these two lines. L39, if we see L39, it is 56. I will be giving as a 50. So now this is my larger slot. What I try to do, I will try to go modify trim. First, I will trim the inner line between these two parallel lines. So this is the inner line I will be removing. Then I will be removing extra lines here. So these are my extra lines I removed. Now simply what I will try to do, I will try to take a line from the draw toolbar. I will be joining these 2 points with a straight line. Okay, this is my blade now. Okay, so geometry is completed. I will simply click on generate. So this is my geometry. I will be verifying whether it is fluid or not. Okay, then I will close the geometry window. Now geometry is completed, so I will try to update mesh. So I will right click on mesh and I will click on edit. So it is asking some geometry modification is done. So I need to import them into mesh. So I will be click on S. So mesh window will going to open. Okay, this is mesh window. You can see there are no matches are found here. So that means actually we deleted this complete line and we deleted these slots here. For that reason it is showing no matches. What I will try to do, first I will delete outlet. When I delete outlet, so the problem was rectified. You can see the problem was okay rectified with the outlet too. Now it is still asking some issue with the wall because this should be selected as a wall. What I will try to do, I will zoom now. I will go to geometry selection. I will select this is my wall now, and this is my slot bleed. It should not be my wall. So this is my wall, and this would be my wall. Okay, it is not selecting. Try to close this one now. Okay, still it is not working. So this is my first. Okay, there is a issue with this selection. What I will try, I will make a simple thing. I will right click on wall. I will delete this one. So because I am unable to modify something here, for that reason I deleted. Then I will be redefining wall. This is my first wall. So it is a bleeding. I should not be selected this one. This after that bleeding, this is my wall. This one is my wall, and this one is also my wall. I will zoom out and how this is also my wall, and at the cowl upper surface bottom surface should be my wall. Okay, then outer is my wall, you can clearly see. So these are my walls now. So I will right click here and I create named selection as a wall because I was redefining wall because I am unable to judge which one was selected, which one was not selected. So to avoid that one, I completely deleted wall and I redefined once again. So this is my wall now. Then final, I have a this slot I was selecting. I mean right click here, create named selection. This is my okay. I will be selecting. I will be checking once again. So this is my inlet, okay. This is my outlet, okay. Axis is okay. Wall is okay. Now I will zoom here. Okay, then I will select. Okay, it's better to go edge selection. At the top, you have edge selection. Then I will select this edge. Right click here. Create named selection. This is my outlet too. Okay. Okay. Now I will be verifying whether it is properly inserted or not. So inlet okay, outlet is also okay, axis is okay, walls are okay. Now finally my outlet. This is my outlet too. Okay, now everything is okay. I will simply right click on mesh and I'll update it. So finally my mesh will going to update. Just I made only one modification in geometry. So that is I deleted the slot, sorry, I deleted the porous bleeding and I created the slot bleeding. That is a larger cross section. Then in mesh, I deleted the wall and I redefined the wall. Then I given outlet too. So I'm closing the mesh window now. So I will try to open setup window now. So I will be setup will be there. So I will double click on setup. Still, it is some changes are there in upstream. So it is asking me to update. So I will be updating. Now you can see this is my setup window. You can clearly visualize. So this is my outlet. This is my outlet too. Here it is representing very clearly. Okay. So now I will be cross checking with my general. General is density based, time is study, axis symmetric, absolute. Okay. These are okay. In modal, energy equation is on. Okay. Now in viscous, I preferred inviscid flow. Okay, then in materials, I have a fluid. In a fluid, I will be verifying whether it is density ideal or not. Okay. So these are the things I need to cross check. Then in cell zone condition, whether it was defined as a air or not. So I will be verifying whether it is air or not. Okay. Now in boundary condition, when I double click on the boundary condition, it is showing axis. Okay, axis is okay. Inlet pressure far field, whatever things we defined, we are making as it is. 26400, Mach number 2, temperature 300 Kelvin. Then interior surface body, whatever interior surface is there, it is interior. Outlet, pressure outlet, we defined pressure outlet should be 150000, thermal should be 300. Okay. Now, so outlet 2. So in previous video we given outflow for the porous bleed. So we'll be preferring outflow for the slot bleed also. Then wall should be wall only. Okay, everything is okay. Then I'll directly go to initialize. Here I will try hybrid initialization. If there is any issue with the hybrid initialization, I will go with a standard initialization. So there is saying that some internal issues will be there. So I will go with a standard initialization. Then I will select on inlet, then initialize. Okay. So standard initialization is completed. Now I'll directly go to run calculation. In run calculation, I will be using number of iterations are 500 calculate. Now iterations are taking place. It is going to converge into last session. It was converged very early. So today we will see whether it will converge early or not. Okay, it was converged very early. Okay, then click on OK. Now here at the bottom you have a graphics. In graphics I will go with a contour. I will select contour 2, or you can create your own contour. It's not a big issue. I have a default is velocity. I will change it to pressure, static pressure, compute, display. Now you can see this is the static pressure contours. Okay, then I will want to see velocity, velocity magnitude, compute, and save and display. So this is my velocity contour. If I want to see Mach number and velocity magnitude, instead of I will select Mach number, compute, and save and display. So this is my Mach contour. So you can see it was finished with the slot bleeding result. Sorry, setup is completed. So I will try to close this setup window. Then I will be saving for future calculation. Okay. Now I will try to open result window. So setup is completed. We see in different contours. Now we'll try to open result window. Now you can see setup is completed, but solution is asking some update. So I will right click on solution update. So it will take some time for updating. After updating of solution, I will try to go to result. Okay, solution is completed. I will be trying to open result window. So in the result, we will see pressure contours, velocity contours, and the density contours. So this is my result window. Now what I'm trying to do, at the top I have a contour. So I will select contour now. I will be adding one contour. Here I have a location. I will select periodic one. When you rotate, then only you understand what in by periodic one, what in by periodic shadow. Okay, so I will select periodic one. Variable is a pressure. I will make it as a number of contours are 500. Click on apply. Okay, these are my pressure contours. Our ultimate aim is to, we should have a highest pressure recovery by this bleeding system. Now we will see velocity contours now. So we will, in variable I will select velocity, apply. So these are my velocity contours. It will still loading. These are my velocity contours now. Okay. So if I want to see streamline, I will off now contour. I will go to streamline. Here I will select streamline, start from the inlet. Just I will add number of points, that is streamlines are 500. I will select forward and backward. Click on apply. Okay, these are my streamlines. You can see some streamlines are ending. That means they are going away from the slot bleed. So we'll see that one in a animation. At the top we have a animation option. Okay, I will select animation. Okay, before that there are two are there. I will try to delete one. Otherwise, what we will try to do, we will check whatever we selected, that is streamline 2. So we selected streamline 2. So I will go to animation. Sorry, I will try to go to animation. I will select streamline 2. I will reduce the speed. Then I click on play. So this is how you can see some particles are flowing outside from the your slot. Okay, this is how we finish. Okay, thank you.